So this quick pre-video is about the definition of the dot product. And the dot product is a way to take two vectors, vector A and vector B, and multiply them together. So the definition of the dot product is A dot product with B is equal to the magnitude of A times the magnitude of B times the cosine of the angle theta between them. So if this is vector A and this is vector B, then this is the angle theta, and the dot product is defined as such. You can also write this as A dot B is equal to AB cosine theta, because A and B without vectors over them are just the magnitudes of those vectors. So you'll notice that it actually gives a number. So this is actually a number, it's not a vector. So even though you start with two vectors, you get just a single number back. And there are some special cases of the dot product. One is when two vectors are parallel. So for example, if you have a vector A and you do a dot product with the vector B, these are vectors, so put our little arrows over them, then A dot B is equal to AB cosine of theta, where notice that there's no actual angle between A and B. So we have theta equal to 0, and cosine of 0 is equal to 1, so this is just equal to AB. So when two vectors are parallel, the dot product is just the scalar multiplication of A and B, their magnitudes. When they're antiparallel, so for example, if you have A pointing backwards and you have B pointing forward, then A dot B is again AB cosine of the angle between them, and the cosine in this case is 180 degrees, and a cosine of 180 is minus 1, so this is just negative AB. And then our final special case is when two vectors are perpendicular. So if you have A pointing up like this, and you have B to the right, so there's a right angle between them when they're perpendicular, then you have A dot B is equal to AB cosine of theta, the angle between them, which in this case is 90, and the cosine of 90 degrees is actually 0, so the dot product is 0. So conceptually, you can think of the dot product as sort of an overlap between the two vectors. So in the first one, where the two vectors are parallel, you have a number that is just the multiplication of the two values. So it's a fairly big number compared to when the two are anti-parallel and we get a negative number. So it's sort of like a negative overlap. They're going in opposite directions. And then when the two are perpendicular, then they're neither going toward each other in the same direction or away from each other in opposite directions. They're going perpendicular, so the overlap, in a sense, is 0. So there is one other formula that's equal to the dot product, and that's the formula given here below. So this is equal to the definition of the dot product above. It's just written in component form, where vector A is AX comma AY, and vector B is BX BY. And the reason why this form is particularly helpful is because what you can do is you can actually look at a couple of vectors like this, and if you only have the components and not the angle, you can calculate the dot product. And so here, our A dot B with the two vectors given would be AX minus 2, and then BX, which is 5, plus AY, which is 3, dotted with BY, which is 4, which gives you minus 10 plus 12, and that equals 2, a positive number. Now this can actually be helpful because if you draw out A and B as vectors here, so let's say we draw A starting from here, it's minus 2, in the x direction, and then plus 3 in the y direction. So our a vector is going to be something like this for what's given here in the question. And then our b vector is plus 4 in the x direction and up 5. So our b vector is something like this. And let's say you had a question where we asked, what is the angle between a and b? Is this angle, is it less than 90 degrees or is it greater than 90 degrees? How would you figure that out? Just by given these component forms of the two vectors and drawing them out. Well, what you can do is you can calculate the dot product like we did here, and since you have a positive number, then in the sense of the overlap, a positive number means that it's much more like the case where the two vectors are parallel, and we got a positive number because we got a times b magnitude, and not a negative number when the two were going in opposite directions. So anytime you have the dot product that gives you a positive number as an output, then you know that the two vectors are less than 90 degrees away from each other. That is, you have an acute angle and not an obtuse angle. And then the final point here is, what is the dot product? So what is a dot a? And if we use the definition of the dot product given here in component form, we actually get ax times ax plus ay times ay, and that's equal to ax squared plus ay squared. And another way to write that is actually the magnitude of a vector squared, or just a squared. So sometimes you'll see an a vector squared, something like this, and the definition of that is ax squared plus ay squared. So that's an introduction to dot product, and I hope it was helpful.